Lesson 3, probability and odds. So you can interchange between probability and odds. You just have to make sure that you remember what your total number is, the total amount. So for example 1, research shows that the probability of an expectant mother selected at random at having twins is 1 in 32. Determine the odds for and against having twins. So what this means is that there's one chance of having twins out of a total of 32. Which means that if you were to not have twins, it would be 32 minus 1, which is 31. So if we were to do the odds in favor, we would do the for, then against. Our odds for it happening are 1, and our odds against it happening are 31. So our odds would be 1 to 31. And our odds against would be the opposite. So we go against first, so not having twins, and for it happening, which is 31 to 1. Example 2, a computer randomly selects a university student's name from the university database to award a $100 gift certificate for the bookstore. The odds against a student being male are 57 to 43. So we have 57 to 43. What that means that if it is a male, that would be our second number here, because it's against, which means that our female's odds are 57. So if we want to find the probability, first we need to find the total. So our total would be 57 plus 43, which is 100. So the probability of it being a female would be 57 out of 100, which is 57%. And the probability of it being male is 43 out of 100, which is 43%. So there's our probability. When you're comparing odds, it's a little bit different than comparing probabilities because they have to look the same in order for you to be able to compare them. So if you were to think about it, it's the same as if you had a fraction. In order to compare your odds, you would need to have the same denominator. So for this, we need to have the same second number. So if we wanted to compare these two numbers, we would have to make our second number the same. So in order to do that, we can always multiply by the opposite number. So for this odd, I'll multiply by 5, and for this odd, I'll multiply by 2. And when we do this, you need to remember to distribute into both terms in the odd. So this turns into 75 to 10, and this turns into 16 to 10. So when they're both equivalent like this, it's easier to see that this is much better odds because you have a 75 outcomes where it happens and only 10 outcomes where it doesn't happen. Whereas this one, there's only 16 times it'll happen for every 10 that it doesn't happen. Similarly, if you want to simplify odds, you can always simplify odds just like you would simplify a fraction. So if you wanted to go back to simplest form, you could divide both terms by a common factor. So you can go back and forth. If you can make them smaller and make them equivalent, you can do that as well. Also, if you just like to make your odds smaller, it's sometimes easier to manage. Example 3. A hockey game goes into a shootout. The coach has to decide which player should go in first for the shootout. The coach wants to use the best scorer first, so it will be based on the player's shootout records. Player 1 has 13 attempts. And 8 goals were scored. So if we wanted to do the odds for player 1 scoring, it would be a ratio of 8 goals out of 13 attempts. We'll just start with that. And player 2 has 10 goals out of 17 attempts. So we're going to compare with ratios and odds and also with probabilities. So first we'll find the probability because that is a little bit faster. So the probability of player 1 would be 8 over 13. Divide those numbers and times by 100 and you get 61.5%. So player 1 has a 61.5% chance of scoring. Player 2 would be 10 out of 17. Divided by 100 is 58.8%. So you can obviously see that player 1 has a higher chance of scoring. Now what we're going to do is we're going to do the odds. So if we want to do the odds in favor, we want to find how many times there's a goal and how many times there's a miss. They miss the goal. So the goal is 8, and to find out how many attempts didn't go in, you would do 13 minus 8, which is 5. So the odds in favor of a goal are 8 to 5. For player 2, same thing. The odds of having a goal are 10. The odds of not scoring a goal are 17 minus 10, which is 7. So it's 10 to 7. So we can't compare 8 and 5 and 10 and 7, so what we're going to do is we're going to multiply our first ratio by 7 and our second ratio by 5 to try to make them equivalent. So when we distribute, we have 8 times 7, which is 56, and 7 times 5, which is 35, so we have 56 to 35, and then we have 10 times 50, 10 times 5 is 50, and 5 times 7 is 35. So as you can see, there's 56 to 50, so this player does have a higher odds of scoring. So it should match the one with the higher percent as well. So you would go with player 1. A group of grade 12 students are holding a charity carnival to support a local animal shelter. The students have created a dice game that they call BIM and a card game that they call Zap. The odds against winning BIM are 5 to 2. So against winning. And the odds against winning Zap are 7 to 3. So we want to figure out which game they should play if you love winning. So first thing we're going to do is we're going to multiply to make our ratios equivalent. So we're going to multiply the first one by 3 and the second one by 1. So they turn into 15 to 6 and 14 to 6. So now we want to compare them so they are the same. So remember, because we're dealing with odds against, this is in the form of losing to winning and losing to winning. So if you were to pick the game that wins more, we know that you lose less times with Zap than you would if you were playing BIM. So the game you would want to choose is to play Zap, because you lose less. So don't forget, when it says against, keep in mind with the language.